everyone! In this video, I will explain how to use Arduino IDE to drive this 1.9-inch screen ESP32 to S3 development board. This development board is a development board with the ESP32 to S3 as the core module. As you can see, now the entire development board is powered on. Then the screen also shows. Now it shows a button in the middle of the screen. We can click this button. The entire button color will change. Click again and it will change back. Here we are running an lvgl program. lvgl programs run on the GFX driver. So we first need a GFX driver to drive the screen. Then the lvgl code can be built on the GFX driver layer. The lvgl library itself comes with some driver code. Of course, this driver code can be found on GitHub. But the entire project has not been maintained for a long time. The entire driver is also relatively old. Therefore, many development boards may not be able to find the corresponding code in some drivers provided by lvgl official. So usually we develop, or when studying, common uses of Arduino. Use a third-party open-source GFX library to drive the screen. I am using this small screen. Now it is driven by a third-party open-source GFX library. We can see. Now we have opened the Arduino development interface. The Arduino IDE has a big benefit. It supports third-party libraries. That is, some open-source libraries on GitHub. We can see some icons in the status bar next to it. This book-like icon, it is the library manager. We can search its GFX library. You can search for Arduino GFX. Then scroll down and you can find a library called GFX Library for Arduino. This library can be used to drive our current development board. Of course, there are many more GFX libraries. It may not be found in this library manager. You can search on GitHub. Find some related libraries. For example, there are some special driver chips. Driver chip models that can be used. Go search for the corresponding GFX library. Check if your development platform is supported. For example, I use our development board platform. What is the model of MCU? Our MCU is the ESP32 to S3. Maybe some use STM32 or Raspberry Pi. Or some other MCS may have different support. So everyone needs to find a third-party driver suitable for your own development board screen. Of course, there are other ways. Find similar drivers. This driver is different from the ESP32 official IDF driver. It is an Arduino only, or a driver under the platform iOS platform. So this driver corresponds to the specific version of ESP32. There may be many incompatibility issues. Our first step is to connect this development board to the Arduino IDE. You can see. First, we find the tool in the menu bar. Toolbar menu. Then find the development board. Inside the development board, we chose the ESP32 to Arduino development kit. First, we need to choose version 2.0. I have two versions 2.0 and one version 3.0 installed on my computer. It should be noted that this GFX library is not compatible with version 3.0. We can only choose version 2.0. There is no problem with 2.0, 17, and 2.0, 9. Then select ESP3 to S3 development. Module this option is selected. We have selected here. We won't click anymore. Click to exit directly. In addition, you need to select the corresponding port number to facilitate program upload. We are now the 7th serial port. Another USB of our development board is connected via USB-C-DC. So the status of USB-C-DC here is enabled. It is the enabled state. Then another thing to note is that the flash size should be selected to the flash size corresponding to this development board. That is, this development board has 16M flash. Then PSRAM is OPI's PSRAM, open. Other options can be selected based on specific circumstances. You can try some. For example, the corresponding flash partition tables can be modified. Of course, if your program is relatively small, you can use the default. For other contents, you can write your own program or some errors given by Arduino IDE or other warning information to adjust if an error occurs while uploading the code. Or when an error occurs, it is best to first adjust the hardware configuration of this development version to see if it is appropriate. Here we will explain mainly basic configuration. One is USB-C-DC. If you choose the wrong, mainly affects serial port communication. That is to say, if you choose the wrong, you will not see any information in the UART monitor. In addition, if the flash size is selected incorrectly, there may be an error in uploading the program. PSRAM is not turned on, or choose the wrong words. It may also be easy to make mistakes when running the program. Here we have configured it correctly. Then we can run this whole. This program is already running on our development board. This program is based on the header file of Arduino GFX library. Related GFX libraries referenced. Used to drive the entire screen. Then lvgl is used to create this button. We edited this button on purpose. It displays larger text. The text above is in a relatively large font to make it easier for everyone to see this effect. Next are some definitions of GPIO pins. First of all, this screen is a touch screen. It requires 4 pins. For 1 to C pins for 1 communication. The I to C pins are 4, 46, and 9, mainly used for communication. Then there are interrupt pins and restart pins 3 and 8. These 4 pins are used as a driver for the screen. The screen driver and screen display are actually separated. The two are physically separated. So I can drive the display. Can also drive touch screen. Can also be driven simultaneously. No direct impact. Of course, if you don't drive the touch screen, your whole operation is useless. Of course, if you don't display the screen content, that is, it does not drive the screen. If only touch is driven, you can use this touch screen as other attributes. For example, when you touch, although the screen is not displayed, but the program works. You can output the touch coordinates in the serial port. Then there are some parameters of the screen, including the length, and width of the screen. The resolution of this screen is 320/170. So here the length and width of the screen are defined as 320/170. In addition, TFTBL is 38. That is the backlight pin, connected to pin 38 of the ESP32 module. Because the entire screen is backlit, let everyone see the screen display content. If the backlight is turned off, the whole screen is black. No matter if there is anything on the screen, it cannot be seen. So there needs to be a backlight pin. The following line is actually a duplicate of the above line. No use. We can delete this line. The following is about the GFX driver. The first is the ESP32 SPI driver. Here you can select this function ESP3 to S3. Because the driver IC of our development board is GC9307. The driver it is compatible with is the entire Arduino GFX library. It is compatible with GC9307 and GC9A01. So you can directly use GC9A01 to drive this screen. Because there is no dedicated GC9307 driver in this library. First, this driver includes two functions. The first one is the SPI pin initialization. As you can see, 4 pins are used here to initialize the SPI communication. You can see that the usage status and specific information of the corresponding pins have been displayed here. Here are some specific parameters of the screen. If you are familiar with some of the uses of the screen, everyone can understand the specific meaning of these parameters. There may be some other abbreviations for individual parameters. You can use this abbreviation to find the corresponding. The following function is a function of the GC9A01 driver. Of course, we use this function here to drive 9307. These are the default values. Then pay attention to. This involves the length and height of the screen. Height and length are shown here. In addition, there are some basic screen initialization parameters. Because it is an SPI screen, the entire driver function is relatively simple and direct. After these two functions are driven, we can initialize GFX. Next are some basic lvgl functions. The basic format of its functions is the same for different screens. Just some information needs to be changed. Here is the refresh function. It is the entire refresh of the screen. Next steps. We can look at it in its function. Here is the initialization function. You can see. First, initialize the serial port. Output lvgl widget demo in the UART port. This outputs a string. Then GFX starts initializing. You can see the start of initialization. Then this is its default frequency. This frequency can enter some custom frequencies. Can also be the default value. Then, because we use GC9A01 to drive, therefore, a color inversion function is required for 9307 to be compatible. Otherwise, the color will be a problem. So this function is specially set for 9307. Next is the backlight. Backlight on to C. Set the output mode of the GPIO pin of the backlight. Then put this pin in a high-level state. You can see the initialization driver of the touch. After touch initialization, lvgl initialization begins. Then there are some specific functions related to lvgl initialization. You can see it here. Here is an initialization parameter for a double buffer. That is to say, we use double buffer areas, a buffer for writing, a buffer for display. Swap the two. Then writing and displaying as an exchange will be very fast. Of course, you can also use a single exchange zone. Display effect of single switch area. In other words, the overall performance is not as good as the double switch zone. The dual switch area is separated for writing and displaying. But because of the entire flash operation, PS RAM operation, writing and displaying can be done very quickly. Writing and displaying can be done very quickly. Reach for a quick display. Next is the initialization of the screen driver. Another is the initialization of the touch driver. Touch driver, we can delete the touch driver here. Then just initialize the screen driver, creating a basic lvgl application. Because the entire screen driver and touch driver are two tasks, we use rows to create two independent tasks. Make sure these two tasks do not interfere with each other. If the screen driver and touch driver are in the same task, the screen may freeze when you touch it. So there must be a task scheduling function in it. Touch and display should be separated. This is also a trick used. Of course, if you are interested, you can continue to optimize this program. The entire program still has a lot of room for optimization. Finally, the loop function. The loop function is the content of the entire loop. Generally, it is a loop sentence of lvgl. Here we mainly explain. The program made by Arduino IDE is very easy. Because the entire Arduino supports many third-party libraries, it is very easy to add third-party libraries to the entire project. It enables everyone to quickly implement prototype verification and prototype construction. But relatively speaking, the programs made by Arduino, there may be some performance flaws, or it may cause some low performance. If you want to achieve higher performance, it is recommended that you use Arduino for prototyping in a production environment. But when actually using, it is best to use ESP32 for production development. For example, after using Arduino to do a prototyping experiment, transfer code to ESP32 brand, because after the prototype is verified, you can directly replace many codes with the corresponding codes on ESP32. Although ESP32 may be more difficult to encode, but if you verify the prototype, the whole process will become even simpler. Of course, we usually do some experiments or studies, or some DIY projects. When there are some small projects that make me happy, it's totally fine to use Arduino, especially for small screens. Arduino's performance is also fully sufficient. Okay, this video ends here. Thank you for watching.